It says classify each salt as acidic, basic, or neutral. Can you explain why? And this, again, this guy didn't explain it, but I'll do my best to explain this for you as well. So I have NH4Br. I have also KCl. I have also NaHCO3, and I want to explain whether or not these guys are acidic, basic, or neutral. So the first one we have to do is, are these ionic compounds? And in this case here, or what we want to do is we kind of want to write the reverse kind of reaction here. So this here is 1. This here is 2, and this here is 3. So I want to break these guys up into these ions first. So let me write this down here. So if I want the ionic form of this guy here, I'm going to have the ammonium ion, which is NH4 plus Br minus, right? Same with this KCl here, I'm going to get simply a K plus a Cl minus. And this guy here, I have Na plus, and I have HCO3 minus, right? So these are all my kind of structures here. If we're looking at these compounds here, what two kind of products could make this salt here, right? In this case, it's actually easiest to start with number 2 here, because this is something we're very, very familiar with. HCl here is simply just Cl minus here. I can say it's HCl. So this here can be a product of HCl plus and then KOH, right? So KOH here. So this is acid-base reaction here, because again, these guys are all salts, right? So salts are being produced by acid-base reactions. So I have hydrochloric acid and potassium hydroxide. Both of these guys are strong acid, strong base, which means KCl here is a neutral salt. So this solution, so number 2 is correct. Second is neutral salt, right? And you can write down the kind of chemical reaction. HCl plus KOH will give you KCl plus H2O, right? So this is very, very easy. A strong base, strong acid reaction here. And then let's look at number 1 here. So again, number 1 here, I have NH4 plus and Br minus, right? So I really don't have, I really care about this NH4 plus because this guy here is a weak acid, right? So if I'm looking at this compound here, I have NH4, let me do this in red actually. So I have NH4 plus. If I add this in water, I'm going to get an equilibrium reaction. And this will get me, and the H is, I'm going to donate this H to the H2O, right? So I'm going to get NH3 plus H3O plus, right? Plus our hydronium ion here. And this here is going to be my my kind of equilibrium reaction when this when NH4Br is dissociated into water. So in this case here, as you can see, I have NH4 on the side, and on this side here I have NH3 plus. So therefore NH4 plus is a weak acid here. So this guy here is a weak acid. So therefore my or actually this guy here is just simply an acid, right? Because again, I'm producing hydronium ions. I technically don't know what the strength of the depending on if I know the K or the KB, right, of the NH4 plus. But in this case, first is acidic, which is correct, right? Because again, this here is producing H3O plus, so therefore this acid here or this salt here must be acidic. So that's good. And finally, for my third guy here, I have Na plus and HCO3. I really don't care about the NH plus. I'm more focused on the HCO3 minus here. So we're HCO3 minus plus H2O, and then I'm going to get, again, if I look here, I have a minus charge here. This H is going to I'm going to donate an H here, right? So I'm going to get this guy would be H2CO3, and I would get OH minus here. So this is going to be a reaction here, and as you can see, I'm producing OH minus, which means this guy here has to be a basic salt. So this solution is correct, but there was no analysis. So let me write down the analysis for them. So solution is correct, but no given analysis. NH4Br dissociates into, so I have NH4 plus, and I have Br minus here. And when in water, this reaction occurs. And then we're at NH4 plus H2O. I don't know how to write the, maybe this guy, that can be my equilibrium kind of sign here, NH3 and H3O plus. Therefore, salt is acidic. Or I can say slightly acidic. KCl. Or I should say KCl is simply a product of a strong base, strong acid reaction. Think of HCl plus KOH. Therefore, salt is neutral. And then finally, I have NaHCO3 dissociates into, this is Na plus, and HCO3 minus. When in water, this reaction occurs. So I'm going to have here, I have HCO3 minus plus H2O is in equilibrium with H2CO3 plus OH minus. Therefore, salt is slightly basic here. So solution is correct, but they didn't really provide an analysis here. So I'm going to say the solution here is correct. And I'll just give the analysis in this case here.